Welcome to a new problem solving session. We are continuing the playlist IIT JEE preparation, and we are working on rigid body rotation dynamics. So this is yet another problem, and this is related to tipping or toppling, whatever you would like to say. And here is a problem at your screen that simply says, what is the least force with which an ice cube sliding on ice can be turned over? The reference of ice means friction is negligible. Friction is not used in this problem. So we are going to solve it. मान लेते हैं कि let the ice cube have a side length d, कुछ मान लिया d, और इसका मास भी कुछ मान लेते हैं. Suppose the mass of the ice cube is m. Yeah. And the force of magnitude F acting on the ice cube at the center of one of its sides. So we have to topple it. So suppose that ये जो side है, this side, इसके center पर हमने एक force लगा दिया है ऐसे कुछ. I would like to show it here in this manner, and this angle seems to be alpha. वो भी assumed है सब. Next, you can show other forces as well. The weight will be acting in this direction, and normal force must be shifted to one of its ends, one of the corners of the cube, so that it can turn or it can topple. So this is the condition that normal force should be acting at one of the corners of the cube. So ये सारे तो conditions हो गए. Now also assume that the cube is accelerating in this direction, in the horizontal direction right now, under the action of this force F. Because there is no friction, so one component of force, horizontal component of force, will accelerate the cube in horizontal direction at least. So it is not a big thing to assume that the cube accelerates uniformly in the horizontal direction, though its vertical acceleration and rotational angular acceleration is zero. I'm not assuming any rotation and vertical acceleration right now, because this is the least force required to just topple this cube. And we can write the equations of motion. So you can see here F cos alpha is responsible for this acceleration. So we should write an equation like this: F cos alpha equals mass into acceleration. And in vertical direction there are two forces in upward direction, that is one component of F, that is F sine alpha, and plus normal, and that will be equal to mg. So because no vertical acceleration has been assumed, so this equation is worthy to represent this condition. Now we can write the equations of the various torques. There are forces acting at different points of this cube, and they can produce torque, and since rotational angular acceleration is neglected, so net torque on it will also be equal to zero. So I think we should write, you perhaps know that the basic equation of rotational motion should be written, that means the net torque is equal to 0 about its center of mass, because the cube is already accelerating. So writing the equation of rotation, there is a torque equation at a different point may lead to incorrect results. So to get it right, we have to balance the torques at the center of mass of the cube. And at the center of mass of the cube, this the component of F, that is F cos alpha and F sin alpha, they are creating torques. Gravity is not, and normal is creating torque. I guess normal is sorry, I guess about the center of mass, normal is creating a torque like this. With its moment arm d by 2, it is creating a torque in anti-clockwise direction. And F cos alpha is creating the torque with a moment arm again d by 2. It's creating a clockwise torque. And F sin alpha, about its center of mass, is also creating a clockwise torque. So we can simply write the balanced equation of torques like F cos alpha multiplied by d by 2 plus F sin alpha multiplied by d by 2 minus normal d by 2. That means, or leave the minus sign. We can balance those torques. The clockwise torque is equal to anti-clockwise torque, and so we can write these three equations. And if you can solve these equations together, you can get the value of F, and that in this case you will be getting the value of F equals mg upon cos alpha plus 2 sin alpha. And you have to find out the minimum value of this F, least value of F. So the expression is given, and its smallest value belongs to the maximum of the denominator. And it can be done by trigonometric transformation or perhaps by differential calculus. And I don't need any of this, because I know this cos alpha plus 2 sin alpha, it will be less than equal to root 5. And the corresponding value of alpha will be, if you get in terms of tan alpha, that will be equal to 2. And put these values of the maximum value of cos alpha plus 2 sin alpha is equal to root 2. You can put here root 5. This is basically root 5, and you can put here and get your result. I hope the question must have given in terms of its mass, but if it is not given, still I can answer it, that the ice cube can therefore be overturned with 1 by root 5 of its weight. That means about 45% of it, and that is the answer. The force magnitude should be 1 by root 5 of its weight, the minimum value, F list. You can answer like list value of F is 1 by root 5 of the body weight of the ice cube, of the weight of the cube. And that's all. Thank you for watching.